اوكي، هلا بدنا نورجيكم كيف حل الهوم ورك كان. question number 1 بيقول Newton is using a Newton cradle. This consists of a set of identical solid metal balls hanging by threads from a frame so that they are in contact with each other. She initially pulled one ball to the side as shown. سحبتين. She releases the ball, it collides with the nearest stationary ball and stops. The ball to the furthest هذه will move to the right, immediately moves away. The middle three balls, these 1, 2, 3, the middle three balls remain stationary. Explain what measurement the student would take and describe how she would use them to investigate whether momentum had been conserved in this event. Now, for momentum to be conserved, this means the momentum of this ball must equal the momentum of the last ball. So we want to know what is the mass of each ball. Is in first measure the mass of each ball. ومش غلط لو قلنا by balance. They have to be identical, but even if they are not identical, we will measure the mass of all of them just in case if we need. Okay. Second thing, now we want to know what's the speed just here, not here, and here the speed is 0. So how can we tell what is the speed here? In fact, it's hard to find what is the speed here unless if you have motion sensor and data logger. So we will use the conservation of energy. I know that we did not study energy yet, but we will depend on the knowledge from grade 9. We know that the gravitational potential energy here is changed to kinetic energy here. So if we know what's the gravitational potential energy here, then we can calculate the speed here. So how to know what is the gravitational potential energy? mgh. M, we measured it. Now, measure the height of release and to know what's the speed here just after the collision, it will change to gravitational potential energy. So we will need to know what is the height there too. So measure the height of release and the height after bounce. So we have two heights. Now use gravitational potential energy equal kinetic energy up, down to calculate the speed just before and just after the impact, the collision, where V, our half mass times V before squared equal M times G times H1, the height 1. Masses cancel out. So V equal square root of 2GH. If you want 1, then this is the before, and V after equals square root of 2GH2. Now check if P before, which equal M times square root of 2GH1, and P after M times square root of 2GH2. You can put mass 1, mass 2 if you want. Must be equal if momentum is conserved. And in fact, yes, it will be conserved. And this is the first part. Now, B. Be seeing the student makes the following observations. The ball on the right returns and collides with the similar result. So the first one hits, this moves, hits, similar results. Repeat itself number of times. The second, after a while, the middle balls are also moving. They were stationary, now they are moving. And the last thing, shortly afterward, the balls are all come to rest. Discuss these observations in terms of energy. Now, we did not study energy yet, but let me answer it here quickly. In all, the first observation, I will write it. No, GPE changes to KE changes to GPE continuously. The second one, after a while, some of the kinetic energy changes to kinetic energy in the middle balls, so they start moving. And the third one we say all kinetic energy changes to heat as the balls come to rest. Okay, this is question number 1. Now, question number 2 says explain what is meant by the principle of conservation of momentum. مكتوب عندنا في النوتبوك شو كتبنا؟ قلنا the total momentum of a system is constant. This is the first mark, provided that, and this is what we wrote, provided that there is no resultant external force. Now the picture shows a toy car initially at rest with a piece of modeling clay attached to it. A student carries out an experiment to find the speed of pellet fired from an air rifle. So في pellet هنا في air rifle hits the clay. The pellet is fired horizontally into the modeling clay, horizontally. So this is not projectile motion. The pellet remains in the modeling clay as the car moves forward. The motion of the car is filmed for analysis. The car travels to a distance of 69 centimeters before coming to rest at the time. Show that the speed of the car immediately after it moves is about 1 meters per second. Now here we consider it to be uniform acceleration, so the distance equal u plus v over 2 times t. Now the distance is 0.69 centimeter equal initial, this is what he wants. The final is 0 over 2 times the time times 1.3. Do your calculation, you will find that u equal 1.06 meters per second, so it's around 1. Okay, now state an assumption. Yes, what did you assume? We assume that it's uniformly accelerating, is an constant, and this is in fact not acceleration, deceleration, constant deceleration. Because if the car is not decelerating constantly, then we can't use equations of motion. Or maybe you can say the force of friction is constant because it is decelerating because of force of friction. Okay, now triple I. Show that, and remember when he says show, this means you will use it. Here he said show that, so we will use this speed later on. I don't know when, but since he's saying show that, then this is important. Show that the speed of the pellet just before it collides with the car is about 120. The mass of the car is this much, and the mass of the pellet is this much. Now this is 3 marks question. Now we want to know what is the speed of the pellet. So here we have a pellet, it's moving by speed unknown, hits a clay, the clay was at rest. He said after the collision they stick together and they move together, and we discover that their speed just after the speed of the car and the pellet when it was stuck to it is about 1. We found it 1.06. So is this clear? Where do we use this? Okay, now the speed of the pellet is unknown. The mass of the pellet 0.84 grams. And this is grams, so it's okay. We leave it by grams times speed unknown plus 0 should equal the total mass 97.31 plus 0.84, and because they stick together so they have the same speed, and the speed is 1.06. Now you don't need to change, this is gram, you don't need to change anything. Do your calculation, you will figure out that the speed is 124 meters per second, rounded to 3 significant figures. He said about 120, and this is true. Now, the modeling clay is removed and is replaced by a metal plate at the same mass. So there is no metal, there is no clay, but there is now a metal. The experiment is repeated, but this time the pellet bounced back because it cannot fit in. So it hits this one and moves backward. Explain why the speed of the toy car will now be greater than the original. And here the speed is 1.6. If this did not stuck, if it moved backward, the speed here will be more than 1.6. Why? Now, assuming that the total momentum before is the same. If the total momentum before is the same, if P total before the collision is the same, no change. I mean, it's the same as this case here. The same speed, the same كل شيء. Then the pellet moved backward. So the pellet now has a negative momentum or velocity because it's moving in the opposite direction, right? So let's say previously we had the total momentum before, let's say it was 100. Now if the same number, if the total momentum, which was 100, equal momentum of pellet plus momentum of car, and the pellet is negative because it's moving downward, so backward. So when we take this now, the momentum of the car is equal to the total momentum plus the momentum of the pellet afterward. So momentum of the car now is greater. I wish that this is clear. Now the last part. The film of the experiment shows that the pellet bounces back at an angle of 72. Does not bounce backward exactly like this. No, it bounces at 72. It's like this. Okay. Explain why the car would move even faster if the pellet directly backward. If it was directly backward, then it has only horizontal velocity. If it's an angle, then now there is there will be two speeds, horizontal and vertical, isn't all. Since if it bounces backward, then it will have only horizontal momentum. momentum, which will be greater than if it has horizontal and vertical momentum, because if it's an angle, there will be two components for the momentum, and then the horizontal momentum will be smaller. Okay? Now, the last part of this question, this is again talking about energy, and you see how questions are related to each other. Let me check if we need to do it here or not. Okay. Let me read it. It's okay. Well, the student tests the result of the first experiment by firing the pellet into a pendulum. Did you remember this question? We do it here, and then it do it like this. With a pendulum with a bob made of modeling clay, she calculates the energy transfer. The student data are shown. The mass of the pellet before, the mass of pendulum, and the change in vertical height is this. So it moved like this up to, after it's stacked, up to 22.6 centimeter. Now the calculations. Change in gravitational potential energy, it's going up, mgh, equal the mass, which is this, times this, equal 0.16. Now, this is the total mass, yes, and this is g, and this is right. Therefore, the kinetic energy of the pendulum immediately just after the collision must be the same. Yes, we said the kinetic energy here must equal to gravitational potential energy here. So this is correct, this is correct. Therefore, the kinetic energy of the pellet before the collision is 0.16. This is not necessarily, no. Therefore, the speed of pellet before collision is 19.5. There are no mathematical errors, but the speed is too small. State and explain the statement calculation were correct. In fact, here it depends on a different type of calculation, so we will not solve this part. Now the last question. عم بقول a spacecraft called Deep Space One has a mass of 486 kilogram, uses an ion drive engine. This type of engine is designed to be used in deep space. The following statement in the web: the ion propulsion system on Deep Space One expels يعني pushes 0.13 kilogram of xenon propellant each day. The xenon ion are expelled from the spacecraft at speed of 30 km per second. The speed of the aircraft is predicted to initially increase by about 8. Use calculation